Hey everyone, I hope you are safe and doing good. So in the series of learning C++ programming language, we are discussing arrays in C++. In the previous video, we have seen what is need of array, why you use array, and what is an array, how to declare an array, how to initialize an array at compile time and at runtime. This thing we have seen, right? Now the next thing in arrays are the memory representation of array elements and how to access array elements. These two things we'll be discussing in this video, right? Theory plus practical also we'll see with the help of program. I'll show you on my laptop, right? Now, before moving further, let me just tell you one thing. If you are preparing for GATE 2024, then I have an exciting news for you guys. An academy is conducting All India mock test for GATE 2024 aspirants, which is on 24th of December. And the important point about this is you can enroll for this test freely. You don't need to pay anything, right? The link you will get in the description box of this video, right? Now, why this test is so special? Because here you get a chance to win up to 100% scholarship. Yes, you heard it right. Plus, it is All India live mock test, so you have a chance to compete with thousands of learners from all over India, and you will get your All India ranking. And by that you will get to know where you stand among the other learners, right? How your preparation is going on. So actually it's right time to test your GATE preparation. And this test has been curated by their top educators based on the latest exam pattern, right? So you will get here actual exam like experience, which is definitely help you when you are going to sit in actual GATE exam. So the enrollment link and the other information related to this exam I'll put in the description box of this video. You can go and check out, right? Now let's discuss memory representation of array elements. See, we have discussed if I want to take array of 5 elements and I want to initialize it at this time only, like 1, 2, 0. Only 3 elements I have, so remaining elements would be 0, right? Data type, name of array, size of array, and something like this. If you don't give size here, that is also fine. Size would be automatically, you can say calculated, right? But here the size would be only 3 according to this, because we have given 3 elements only. But if suppose you give size 5, right? So how in memory these array elements are to be stored? So this is like we have memory blocks, right? Something like this. You can represent this horizontally or vertically, it's up to you. I'm comfortable with this thing horizontally, right? So suppose 1 byte, I don't know the address. Suppose the address of this 1 byte I'm taking 100, 101, 102, 103, 104, 5, 6, something like this, right? I don't know the address, I'm just supposing the address of each byte, right? Now how much memory to be allocated first? This would be calculated, right? So the type is integer will take 4 bytes, 5 integer, the size is 5, so 5 into 4, 20 bytes would be allocated by the memory manager, right? And these bytes would be allocated contiguously in memory. Like if I start from here, if the memory manager has started to allocate memory for this array from here 100, so till suppose here is last is the address of last byte would be 119, right? From 100 to 119, so 20 bytes are there. So these array elements are to be stored contiguously in memory, right? In contiguous memory locations. So now one would be stored in these 4 bytes from here to here. One would be stored in these 4 bytes, right? Then here 2 would be stored in these 4 bytes. Then next 4 bytes, the 0 would be stored. Next 4 bytes, again 0 would be stored. Next 4 bytes, again 0 would be stored. Because only 3 elements we have given, remaining 2 elements would be by default 0, right? So that is why if more simply if I draw this, then we can draw something like this. 1, 2, 3, 4, 5. So 1, 2, 0 and remaining would be 0, 0. So if the address is 100, next address would be 104, 108, 112 and 116. So now the name of this array is A, and in A the address of first element is stored, or you can say this is the base address of this array, base address, the starting address. So in A the name of the array stores the address of the first element, right? So these are, by default considered as pointers. But sometimes, except sometimes, if I use something like this, size of operator, with size of operator, if I write down the name of this array, here it is not considered as pointer. It will give the size of this complete array, not just the size of this pointer, right? So here are some situation where array name is not considered by default, as a pointer, but other than that, array names are implicitly considered as pointer, right? So you have to take care of this thing also. Now, if I say array name A, it means it is indicating the base address of this array, right? So this is how memory is to be allocated. Now, if I want to allocate memory to a second array, suppose if I write down here float marks and 10. Now you have to tell me in comment section how much memory is to be allocated, right? So same, float is going to take 4 bytes, 4 into 10, like 40 bytes is to be allocated, but contiguous memory location, right? If we are going to start, it's not like that, maybe from here you can say from 120, maybe from this 120 memory is to be allocated to this marks array, or maybe from some other memory location, maybe from 150 address, or maybe from 1000 address. I'm just supposing this address. It's not the actual address like 100 or 150, no. I'm just supposing it, right? So maybe from 1000 address, starting from 1000. How much byte is to be allocated for this? 40 bytes, contiguously in memory. From 1000 to 1039, 40 bytes, right? It's up to how much data you store, how many elements you store, 1, 2, 3, 4, or 10 elements, right? So this is how the the memory representation of the array elements. So this is how the arrays elements are to be stored in memory, right? Now how to access these array elements? If I'll show you practically also. We will just access, we will print the memory address also of array elements. Don't worry. If I have a int x 5. So if I want to access this, just cout and x, that's it. But in array I have 3 elements in this array. I want to access these 3 elements. So first thing, randomly you can access any element. Directly you can access any element of the array. If you want to access 0, directly you can access. It's not like that you have to go from 1 to 0. No, directly you can access this 0. How? Using indexing. Using index actually. Index. Now this is what main thing here. Index starts from 0 in arrays. So here 0, 1, 2, 3, 4. Maybe you think that how to access, let me just show you the array name, and in these brackets are known as subscript. Just write down the index. Suppose if if you don't know the index start from 0. If I say I want to access the first element, so obviously you will say the position of first element I think should be 1. So it should be a of 1. Means a of 1 will give you first element. A of 2 will give you second element. But no, that is not a case. If you want to access the first element, then index would be 0. Now why this index start from 0? Actually, there was a programming language BCPL. They designed this language. Martin Richard, that they designed arrays in that language in such a way that it would be initiating from 0th index, right? And after that B language comes, after that C language comes, and they followed the same pattern. And C language actually becomes so popular that all the other languages consider C as a base language. So they followed the same pattern, right? Although we have some exceptional cases also, like language MATLAB, Lua, and I think Smalltalk, Pascal. These languages, Visual Basic, in that array starts from not from 0, right? So there are exceptional languages also. It's not like that all the programming language consider this pattern and array starts from 0th index. No. But why now this? In C language actually, This index, I mean this, actually we call this index, this subscript, this is actually offset. It is not the position, first position, second position, no. It is actually offset. Means the number of, or you can say the distance from the first element of the array, right? The distance from the array's head, right? So if I write here, if I want to access this 0, right? So the distance of this 0 from the first element is how much step you need to take to reach to this 0. If you are here, then 1 and 2. After taking 2 steps, you will reach to this 0. So that is why index is 2. Means this is actually the offset from the first element, right? If you want to access the fourth element, the last element. So the last element in this array is how much step away from the first element, the distance. So if you are here, then 1, 2, 3, 4. If you take 4 steps, then you will reach to this last element. That is why index is 4, right? So the first element from the starting is how much step you need to take to reach to first element? No step, because first element is at starting only, right? That is why index is at 0th element. So this is actually an offset from the array's head, right? And it makes, generally the second reason is what it makes, simpler implementation of these things, because in C, arrays are closely tied with pointer arithmetics. I have told you right now, in C, many times this array name is considered as pointer implicitly, except few cases, right? So when you want to access, actually if you want to access any element in the array, so we will write a of here the number index, right? So if I write here, suppose I general, then this would be converted a plus I, like this. The inner working I am telling you, and you have to dereference this to get the actual element. So this star is dereferencing operator. Don't worry, we'll discuss this thing in detail when we'll discuss pointers. Okay, so this is how it is to be converted, a plus I this. Now a is having address of the first element or the base address. Suppose we are taking this example, so 100 plus, here I is what? Suppose I want to access a of 1, right? So I is 1. So 1 means in pointer arithmetic, this 1 means it's not like that it will become 101. No, this is what address. So if you add 1 here, means address of next element, not 101. And one element take here, because it is integer 4 bytes. So address of next element is what? You have to add 4 here. So this 1 means actually plus 4, right? It's plus, actually plus 4. So 104, and this is dereferencing operator. So at 104 I have 2. Dereferencing operator will give the actual value 2, right? So if I want to access the first element, maybe you will, like you think that it should print 1, but it is printing 2. So if the array index starts from 1, the first element we are never gonna, fetch, right? That is why this is at 0th index. I hope you got this. So if I want to access like a of 0, first element 0. So I is what? Here 0, right? So obviously 100 plus I is 0, so same 0, right? It is at first element only. It is the first element only. So address 100. So at 100 at first element is 1, right? So you will 1 would be printed here, right? It's okay, we'll discuss this pointer and all in detail, right? Just a brief, just to make things clear out, like why index starts from 0, right? If you got this, you can let me know in comment section. Yeah, we got this. Why index start from 0? You can just write down the answer. If you're not getting this, you can just let me know in comment section. We can make a different video on this, right? So like this, we can access array elements. So if you want to access any element, right, in array, so index would be from 0 to size minus 1. Size of array is 5, so 0 to 4. So like this, a of 0, a of 1. In cout, we can simply write cout a of 0. So it will give you output 1, right? And to access these, obviously we need a loop, because if I want to print all the elements, so one way is you can simply write cout. If you want to print all the 5 elements in this, so simply one way is 5 cout statement, you can write down a of 0, a of 1, a of 2, a of 3, a of 4, something like this. It will give you all the 5 elements, right? 1, 2, 0, 0, 0. But if in array I have 10 elements, I have 100 elements, I have 1000 elements, so obviously we cannot write down 1000 statement, cout statement, right? Because here something is repeating, as you can see. Cout, we are accessing A, only this index is changing, right? It is increasing, by one number, first 0, 1, 2, 3, like this, right? So obviously this is what repetition of these statements. So for repetition we use loops. That is why we use loops in arrays, right? To access all the elements, we can just write down one for loop, while loop, do while loop, or range based for loop, and they are only single cout statement. How to write that I'll show you. This I'm telling you this because I have seen one comment like, why in array we use for loops to get to access elements in from the array, or to get input from the user. Why we use loops? So this is the reason we use loops, right? Because of this repetition, right? Now let me just show you practically. Okay, so this was we have discussed in previous video, how to declare array, how to initialize the array at runtime. This is at runtime. See, we have taken a loop. You can take for loop, while loop, or any loop. I have taken for loop to initialize arrays because we want to enter 5 element from the user. We are going to ask 5 element, right? That is why obviously we will repeat, enter first element, enter second element, enter third element, fourth element, 5 element, right? So we are repeating here. So that is why we are using loop. So array index start from 0. So I would be 0, less than 5, 5 plus plus, and just to take input from the user we use C in this object, roll number, and in subscript simply I. So at first I value is 0. So at 0th index value would be stored. Then whatever you will enter, I value becomes 1. Then at 1 index value would be stored. Then 2, 3, 4 till 4, right? And how memory is to be allocated, that also I have shown you. Let me just show you address. If you want to print the address of array, okay, it's not A actually, it's the the name of the array here is roll number, right? So let's just run this and we'll see what output we'll get here. Enter the roll number, first, second, third, fourth, 5. So this, the address is in some hexadecimal form. See, 0x61fe f8, right? And if you want to print the address of first element, so if you don't write this address of operator, just simply roll number I want to print. Let's run this and see what output you will get here. See, then also you will get address. Why so? Because array name is array name. This contains the address of the first element. It itself acts as a pointer. That is why no need to write down here address of. So to access the base address of the array, just simply write down name of array. And I have shown you, it will give you address, right? No need to write down the address of operator. But if you want to access, suppose address of first element, second element, third element, fourth element, all the element, then obviously you need to write down address of. Because in array we have just the base address of the array in array name, right? Or you can say the element, the address of the first element. So simply I'm just writing here address of roll number 0, 1, 2, 3, 4. This is what, and the base address of the array as well, right? So let's save this and run this. Let me show you what kind of output you will get here. Okay, you have selected this, it's okay. Just run this again, there is no error actually. So enter the roll number 1, 2, 3, 4, 4 and 5. Okay, address we are getting in this line, so you have to put a ENDL or /n also for new line, right? Now let's run this. See, address is this first, F8 starting two address are same, because the base address of the array as well as the address of first element, obviously that is at 0th index, so that would be same. So as you can see, these are same. And then different. If you add 4 byte, then you will get the same address in the first address, right? 8 plus 4, 12. 12 is in hexadecimal, it's C, right? Something like this. Now same, see here we are repeating the same line again and again for printing everything, for printing the address. So you just put these things also in a loop, right? For loop would be from 0 to 5, and there just print address of roll number, and in bracket just put I. That's it. So you just do this thing. This is assignment for you guys, right? Now this is how memory is to be allocated contiguously. If you run this again, if you just pause the video there, write down the address hexadecimal form, and then starting take the first address and add 4 byte, 4 byte, 4 byte, you will get the consecutive those same addresses, right? Now next is how to access array elements. So let's not print these addresses now. Now how to access? We have entered 5 roll numbers. So how to access those 5 roll numbers? One way I have told you, just write down 5 cout statement, but no, that is not I want. So we'll just take a for loop, same. So here obviously you have to declare this I first, int I. I mean you have to tell the data type also before using this I, because this scope of this I is within this for loop only. So we cannot use this I here. If you declare int I here, then you can directly use in this for loop throughout the program. I is equal to 0 without writing this int, right? I hope you are getting my point. So 0 to 5 I plus plus, and how to access the values, to print values we use cout, to take values, to input values we use cin. So cout and just name of the array, in subscript the index or the offset, so that is I, right? At first I is 0, then 1, then 2, then 3, then 4. So like this will be able to access all the elements. 1, 3, 4, 67. Okay, you have to decorate it a little bit, obviously that new line after printing every roll number. So just enter roll numbers. One 34, 56, 78, 45. So again it is printing 134, 56, 78, 45, right? Before this for loop, just to decorate it a little bit, you can just write down the roll numbers are like this. So if I run this, the roll numbers are this, right? So this is how we can access, or if any particular roll number you want to access, like at maybe 0th element or first roll number or second roll number, something like this, so directly also we can access using index. So rather than this for loop, like the roll number of first student is, so roll number of first student means obviously the first roll number would be at a 0th index. So just in subscript just write down 0. See, the roll number of first student is 23. So it will print 23 here. So directly also you can access. You can write down a 0 or either 1, 2, 3, 4 till 4. Right. Now one thing is, if I want to access a roll number of roll number 6. So obviously there is no index 6 because there are only 5. The array size is 5. So index would be from 0 to 4. But I am accessing 6. Right. So what do you think? Pause the video and just give it a try. What it should give? I think it should give an error. But no, it will not give any error. It will give a garbage value. Let me just show you this. See, the roll number of first, obviously this we haven't changed, but see, the value is any garbage value. Why? So because there is no bound checking in array. This is the major drawback in array. Bound checking means it is not checking the boundaries. You have to, if you are using array, this kind of thing, you have to take care this array of the size or the boundaries of the arrays, right? If you will access anything outside or beyond the boundaries, if it will not give any error, it will just give you any garbage value or just unexpected output, right? So this thing you need to take care. So the drawback, one drawback is this, there is no bound checking in arrays. Fine. And arrays are of fixed size actually, and maybe next drawback you can write down, like this contains elements of same type, right? This can be a drawback, but advantages are like more than one element we can store under a single variable. I'm using arrays, and these are simple to use. Fine. Second thing is you can directly access any element in the array with the help of index. That's it. That is very simple. Accessing is very simple, right? When we will discuss list, then accessing is not that simple. You cannot directly access any list element. You have to start from first element, then you will go to second element, third element, fourth element, like this. If you want to access the last element, then you have to start from first, second, third, fourth, like this, right? Except the case it is that double linked list, but that is different, concept. The linked list, actually linked list is in Python, but here that is linked list, right? So after arrays we will discuss those also. So I hope arrays are clear to you guys. So this is about 1D arrays actually. So in the next video we'll see 2D arrays. So now I'll see you in the next video. Then bye bye, take care.